1 byte or what? Well, the ones that were in the other class already know, right? But the thing is, the way to answer that question is first to ask, how many bytes does the system use for an int? In this architecture, we know this is 4 bytes, right?
Yeah.
So when I define a pointer to an int, if I increment the pointer, it increments by 4 bytes. Because you gotta think about pointers like array indexes. So when you have an array of ints, and then you go to the next index, it doesn't go to the next byte, it goes to the next element of the array. And if each element uses 4 bytes, in terms of bytes, it moves 4 addresses. Okay? Moreover, when I talk about a data struct, which is something way larger than just 4 bytes, the pointer is also going to increment accordingly. Okay? And when I look at the memory, because everything has an address, right?
Yeah.
Somewhere in the memory, I'm going to have my GPIO-A, my GPIO-B, and this is going to have an address, which I don't know yet, but I know it has an address. Now, how much separation is between the two? Well, to understand that, we kind of need to look into the details and dig a bit deeper, right? Because if we go here to the notes and we look at pointers and data structs and we scroll all the way to the end, I kind of started, I gave an introduction to this thing. And if you're curious enough, you could define a data struct in C of the same type and see what is the size of it. But most likely it's going to be 4, because everything is 4 bytes, right? Oh, but this one is an array. So this will be 8, right? But let's see. 4 times 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 times 9 is 36. Plus 8 will be 44. So chances are that the size of this struct is 44 bytes. If you were to define a pointer to that data struct and you increment it, you will increment by 44 bytes. And moreover, the address of these two, if they are actually consecutive, they will be separated by 44 bytes. Because this is the size of the struct. And the registers and the modules, the peripherals in this micro are actually built into a data struct because they are so complex that it doesn't make any sense to have a single register. It's better to have it in a data struct, sort of like encapsulated. Okay?
That's a lot of data it's taking, like a lot of space it's taking up.
Yeah, so it's important that we do understand that. Okay? Any questions about that? Okay.
Lots.
So that being said, we're going to start talking now about the board. Because we kind of have an idea of what the C language is. Now, how do we start working with this board? Everybody should have this board at this point. And it should be a Nucleo G0B1RE. If yours says something different, you got the wrong board. And I hope that is not the case. I'm pretty sure that's not the case because we are very careful. But even if that was the case, we can fix it. We can. Now, I'll give you some time so you can do some check. This board is what we know as a development board. Okay? And this guy here is the main microcontroller on this board. Okay? I said the same thing in the other class. It is wrong to refer to this whole thing as the microcontroller because it's not. It's a development board. The microcontroller is this guy. Okay? And this is the brain that we're going to program.
So the CPU.
Okay? Yeah. Now, it looks like there's another brain here. And it's also ST something. Okay? How is that? Well, I think in the past, I might have talked about what happens when we're running an application, a console application in Visual Studio, right? What happens with the process when we debug, when we build and all that? You guys talk about that? Yes, I did? Yeah. So what happens there is that when we build, it creates a binary that goes inside the bin folder, and that is an executable file.
Oh, yeah, you did.
And the key thing in there is that what we build and what it runs, and everything happens on the same machine. So we build, we run it, and everything happens on the desktop computer. Okay? And when we debug, if we use a debugger in Visual Studio, we can stop the execution of the code in this machine, and we can step through line by line on this machine. Now, in this case, we're going to use Sega Embedded Studio to build a binary that ultimately is going to run here. So it's quite a different scenario, which is why in this case, you mentioned that word some time ago, right, Rex? You used the word cross-compiler. And that is exactly what this compiler is. It's a cross-compiler. And why it's called cross-compiler? Because you compile here, but the code doesn't run here. Run here. Okay? And now the obvious question, when you say that, how does it even happen? Like, how can you make something that compiles here, ultimately run here? You need some sort of interface. And the interface is this guy. That's the purpose of that guy. Okay? So, since they want to simplify our development, they sell us this development board that is a combo. So it's basically a microcontroller with a debugger microcontroller. Okay, so this micro here comes already with a firmware that is running and that it can be actually updated. And the purpose of this firmware is to be the interface between this guy and the computer. This guy has a USB port on the top, so that's how it connects to the computer, and it connects to this guy through some traces that are defined here. But this piece of the board could actually be broken off. And if you do that, you break the interface between the two, and then you can only debug through this piece. I will talk about those pieces in just a moment. Moreover, if you were looking at the past, things weren't that simple in the past. In fact, you may have heard already that we're running JLink on this board, right? So I'll explain the ST-Link JLink thing in just a moment. But the JLink used to be something like this. And I do have some of these already. I still have some of these boxes, and I can show them to you next class, maybe or sometime in the future. And these boxes actually contain inside a microcontroller, and this interface had to connect to the board and that to the USB. So in the past, we had to be running the micro with one of these standalone things. Nowadays, these standalone things, they still exist, but they're more compact. They're like this, right? And when would you need this? If you were to design your custom design, then you need one of these to program your board, right? But the guys from ST, they are giving us a combo, right? So everything comes in here. But eventually you could break this one off and use it as a standalone debugger and use this pin to debug a different micro of this one, okay? But everything is in here. Another important thing is like when we're debugging our code and we're putting a breakpoint and stopping the execution, again, in Visual Studio, everything is happening here on this machine. How does it happen here? You've been so far doing just debugging with the simulator, but now, very soon, you're going to start doing debugging with this real guy. So how is that debugging going to work? Actually, when you put a breakpoint and you stop the execution, well, this guy needs to come into the picture. So the software, Sega Embedded Studio needs to send a command, and this guy has a protocol of communication with this one. And at some point, it's going to tell this guy, hey, stop. Now go one more line. Step over, step into. And all those things are happening. So that's the debug protocol that's going on here. Okay? So it's quite complex. But it is important that we don't have to understand all the details, But we need to understand that there's an interface going on here, which is why if our J-Link is not recognized, nothing will work, okay? Now, the board comes with an ST-Link, but we then eventually convert to J-Link. I don't know if we've done that, actually. Have I
No,
shown you
no.
that? I have not. Okay.
We probably don't even know what the heck J-Link even is.
Okay, so let's start from there. A little bit of history. Everything starts from here. Well, there are other protocols, but JTAG is a debugging protocol used for microcontrollers that has existed for a very long time, and it still exists. The problem with JTAG is it uses many pins, like from 10 to 20 pins, depending on if it's full JTAG or whatever. So ARM, which is the manufacturer of this core, now this is ST. Why is it ARM? Well, because the micro that we're using is an ARM Cortex M0 Plus. And I always do this analogy, we will hear repeated if you were here. When you have a video card, you have a GeForce, that is the chip of the video card. But the vendor of the video card could be what? Give me examples.
Gigabyte.
Gigabyte, what else?
Kilobyte.
Asus.
Asus,
Oh, okay.
Zotac, whatever, right?
That's-
But the chip is GeForce. So this is the same idea. The core of this micro is ARM. But the manufacturer, the vendor could be ST, could be Texas Instruments,
Or
could be
partner.
NXP, and all of them will manufacture similar micros with the same core. Okay? So that is interesting because that means that the debugging protocol is the same for all of them. That is why it's such a stunt. So ARM took this JTAG and create a simplified version of it, which is called SWD, which stands for Serial Wire Debug. And the serial wire debug uses 3 pins: SW clock, SW DIO, S serial wire clock, serial wire debug input output. And it uses a hard reset pin, which actually resets the micro whenever it needs to start debugging or flashing a binary. Okay? Now this is a standard from ARM. Now, ST built ST-Link. ST, okay? On the other hand, we have J-Link. Who is the creator of J-Link? Who handles J-Link?
Second.
Sega. In fact, if you go on their website and you go to the links that I've given on Brightspace, the J-Link software gets downloaded from Sega website, okay? So obviously, we're using Sega Embedded Studio. So if we wanted to work off the shelf, it will work with J-Link. We can make it work with ST-Link, but we need to do extra work. And that's why we're asking you to convert the ST-Link to J-Link. But the interesting thing is that both ST-Link and J-Link are implementations of SWD. So they are just their own version of this guy, which is why they are interchangeable. The hardware that we have here can run actually ST-Link or J-Link, which is why we are going to convert this ST-Link. This is basically the firmware that comes in here, and we're gonna change it to a J-Link. Okay? Does that make sense? And when you buy the standalone debuggers, you can buy an ST-Link, which comes in here, or you can buy a J-Link that comes in here. But in this case, we got it built in here. When you design your board in 2750, later on, 2 semesters ahead, you might want to go back to ST-Link. And the only reason for that is because this one is $20 versus, or 17 versus 80 something. Yeah, so J-Link is a bit more expensive.
Yikes.
But it's better, it's faster, which is why we converted to J-Link. Okay? Questions about that? Okay. Don't worry too much about that, but that is general knowledge that we need to know and to give some context of what's going on here. Now, let's say you are given this board and you need to start working with it and you know nothing about it. Where do you start? What do you start with? Any ideas? What would you ask for? What kind of information? Huh?
Schematic.
Board schematics, that's a good one, right?
How do I plug it in?
Yeah, well,
Probably the first one.
yeah, the board schematics will actually, will tell you that, but then you may need some sort of like manual from this team, right? So when we go here, data sheet, exactly. And lesson number 2 is where we have all this information. And if we scroll down, I'm not gonna go through the objectives. I think I've talked about the same thing here. You can read through this lesson. Now, before we go into the details, we got on the top a picture of the board, right? Then on the bottom, we have this layout of the pins. And this is important because let's say if later on we want to target something in the GPIO port, and let's say we want to go on PA13, which means the pin 13 on the GPIO A. We need to locate that here, right? Which is why we got this. The PA13 is here. So we know we need to tap onto that pin, okay? Now the pins on the inside are shared with this light blue Arduino connector, okay? So basically the 38 here is the same as the 6, 36 the same as the 5, and depending if you're using a female or male jumper wire, you can use either or, and they're interchangeable. The ones on the side are unique. You got the 3 volts, the 5 volts, the grounds, etc. Okay? And for the development board, you got the schematics, as somebody already mentioned, and you also have the development board user manual. Okay? So we're gonna start by looking at the development board schematics. And I think I already downloaded this one. Yeah. I'm gonna open it with Adobe because I just don't like Edge. Now, when you take 2150, you will learn a little bit of how to use KiCad, and that is the software that is used for building boards for doing PCB design. This is taken from a design done with Altium Designer, a more professional PCB design tool, but it's kind of the same idea. And what this is showing is a hierarchical view. So this is like the top level view of the schematics, whereas every single green square is another sheet that has dedicated purpose. So everything is more organized. So for example, the power is in this sheet. The micro itself in this one, whereas the ST-Link is in this one. So for example, if I click on that one, it should take me to that sheet, okay? But don't get overwhelmed with this because this is the ST-Link micro that will get eventually converted to a J-Link. In fact, this is not your micro. If you look, it's an STM32F1003 whatever. It's not your micro. This is the micro that's doing the debug, so we don't care, okay? Go back. The micro that we're going to be using is this guy. This is the one that we're going to be programming. And I can already see a very useful information here, which is the blue switch that we have on the board. Okay, so if we go to the board, there's a blue switch here. Okay, so who can tell me where is that blue switch connected to? Which pin on the port? But you were already here.
What? Who said that?
Someone else. Where is the blue switch connected to? If we look at the schematic, PC13.
Oh.
Excellent. Okay, although to be fair, it goes through a switch breaker, you have to make sure those things are labeled on the board on the back. And sometimes some of these ones are not populated. So you have to make sure that these are 0 ohm resistors. And you have to make sure that they're actually populated. Well, in this case it is. But if it was not, that means that that circuit is open and you have to actually solder something in there to make connection. All right. Now, interesting enough. Can anybody tell me if this switch is active low or active high? Or if you are not able to tell me that, tell me if it has a pull-up or a pull-down resistor.
It has a pull-up resistor on VDD.
It has a pull-up resistor because this one is by default. If the switch is open, this pin is pulled up to 3 volts, so it has a pull-up. Therefore, when you press the switch, it activates ground, so it's active low. And this is important because when we were discussing the bitwise operators, if we wanted to check if the actual button is pressed or not, we were most likely going to look for a 1, right? We're going to mask it, we're going to do an if.
0 here.
So then we need to swap the logic here, right?
Tie to ground.
It's opposite. But that's very common, actually. It also has a decoupling cap just for avoiding debouncing. There's another switch, which is this one. Can anybody guess what this one is for? Based on the labels that we see. By the way, when you see these yellow markers, these are off-sheet connectors. So these ones are the ones that come out of this sheet. So if we go to the top hierarchy, so these are shown here. See, these are the exits of this sheet that go to the other one. So it happens that the debugger pins, and in fact, let's do this right away, because these ones are actually, the labeling here is based on the old JTAG, because they want to make it compatible with JTAG. So the SW clock, which is the SWD pin, it ends up being this one, the T clock. And the SWDIO is TMS. And the reset is just a reset, right? It's NRST. So these are the pins. So the debugging pins are connected to them. Okay. I asked the question again. What is the black button for? Reset. You press it, you reset the micro. So don't press it too often, because every time you press it, you restart the micro. And if it's debugging, it's in the middle of a breakpoint or whatever, then it's gonna probably make the system crash. So make sure that this one is your user button. This one is just for reset. Okay? Any other questions about this? The last thing I checked with the other class, and we're actually going faster in this one. See, every time I do the second iteration, I go faster because I assume a lot of things. Nobody has any questions? Yeah.
How do we connect our board to SIG?
We're gonna use JLink.
Okay.
Yeah, so we have to set up, we have to convert our ST-Link to JLink. We're gonna do that in the second hour. Yeah. So this thing here also looks like it could be broken off, right? Like we just, don't do that, please.
You can.
But if you do it, what happens? What do you think happens? You can no longer debug this guy, because most likely the only possibility for the traces to go from this micro to this one, to use SWD and all that, are going through here. And in fact, in next class I'm going to bring up the design for this so I can show you where the traces are going, right? But you could eventually use this as a standalone debugger if you were to connect to these pins, because the SW pins are actually here. And we can look at that as in the schematic. If we go to this guy, see this header here has the T clock, the TMS, and some other pins, because this one is a full JTAG, right? But it has the TMS and the SWIO, which should be the SWO. No, the TMS, sorry. Yeah, so this one, and this one would be the 3 debugging pins. All right. Come on. Okay. Where was I? For this. We know this. Oh, last thing. When we go to the power, not this one, the micro power. This is the last thing I wanted to show, and that I showed the other class, to be consistent with both. We got analog power, ADD, and we have digital power. Okay? And between the two, we have a switch breaker, and we have an inductor. And this inductor is a specific inductor. It's a little one that is called a turret D. Does anybody know, or can anybody guess, why do we have an inductor between two power supplies?
Because, actually, I'm not gonna answer that.
Any ideas? If we go to back to our 1000 course, what is XL? Phasers. How do we define XL? Yeah, it's the reactance, but what's the formula for it? It starts with a 2.
2 pi F.
2 pi FL.
There you go, you know.
Okay? When the frequency is very high, how is this? Very high. So, if we have a very high frequency, what is this then? What is a very high impedance or very high resistance? What is it in simple terms? Hmm? When you have a very high impedance, an infinite impedance, what is it? An open circuit. At very high frequencies, this is an open circuit. And why is that? Well, the purpose of this, and you're going to deal with this a lot in this course, when you're dealing with digital signals that are going on and off, there's a lot of switching noise. And that switching noise feeds back into the power supply, and it creates multiple problems. And the analog power, it needs to be consistent, because that's where you're reading your sensors, right? Your analog sensors. So this guy needs to be isolated from that noise. That's why we have this here. At very high frequency noise, this thing is an open. Now, I made the same question, so you're not allowed to answer. What is the frequency of a DC signal? Nobody was able to answer in the other class. 0. Excellent. Did anybody know that?
Yeah.
At least
I
a
know that.
very clean DC signal 0.
Yeah, it's 0 frequency. So let's go back to this. At 0 frequency, what is this then?
0.
0. It's the opposite of an open. What is it? What is the opposite of an open circuit?
Circuit.
Short circuit. So when this is DC, clean DC, no problem. This one is the same as this one. The moment that we start having switching noise here, this guy is protected. That is the purpose of that. Okay? Basically filtering. It's just filtering the current though. Because if we were using a voltage filter, like a high pass or low pass, we will be using some sort of like RC filter, right? That would be a low pass. Anyways, that's the schematic. Now, connecting the board? Why not? So I suggest when you connect the board, and there's a video that I recorded already for the session I did on Saturday to have students that are in micro two that don't know this. But a good exercise when you're connecting this board is to have your device manager. Oh yeah, sure. Okay, let's take a 2-minute break. But get set up on the computer, either the desktop computer or whatever computer. And you want to open the device manager.
You don't have to plug it.
So the thing is, you need to buy a piece,
No, it's not. Just use your Android charger.
like buy a piece out, so that you can take this. There's some entry that.
Where you pointing at?
In the closet?
Oh yeah, I can let, but it's just a loan for the class.
May I please, get a loan?
If anybody needs a micro USB, I can lend one, but it needs to return. How they work? 6 1. Okay, but are they from here? Why? Yeah, you can have this one. No, but please return it because that is supposed to be that's better.
Take his ID card so then he comes back with
Okay,
it.
so open your device manager. If you do it on the desktop, it's going to complain that you're not admin. That's okay. You can just still see, right? It says this, or you can still. Yeah. You right click on the window here and you go device manager. It will open up this. Okay, so you're going to connect the micro USB cable to the board and something's going to pop up. In my case, it's going to show a J-Link UART port and a J-Link driver because this one has been already converted to J-Link. Now, let's go to Brightspace. When you downloaded Sager Embedded Studio, I'm assuming that you also downloaded the Sager J-Link software?
No.
Well, if you didn't do so, please do so and install it if you're working on your laptop, because on the desktop it's already installed.
How is it?
If you're working on the laptop, go to Brightspace and go to Tools and Documentation. Remember, J-Link is from Sager, so go to Sager and download the J-Link software from here. Yeah, your question?
Yeah, it's not. It's not showing.
It's not showing anything?
Yeah.
Okay, yeah. If it doesn't show anything on your laptop, it's because you have nothing installed. So ST-Link also needs drivers, okay? So the first thing you gotta do, if it's the first time you're using your board on your laptop, remember, here everything is already installed. But on your laptop, you have to first install the tool from ST Tools and install QProgrammer, this guy. Because QProgrammer will install the drivers for your ST-Link. So do that. QProgrammer, in case you haven't done so. For the ones that have it already installed, there's another Sager tool that is called ST-Link Reflash Utility. This one is a portable tool, and the sole purpose of this is converting the J-Link to, the ST-Link to J-Link, and vice versa. Why it doesn't want to download? Maybe I already downloaded it. I think so. That's why. Yeah. This is a portable tool. See, it's 2 files. When you click this, it opens a DOS window. In my case, I converted mine. It's too much noise. I converted mine already to J-Link, which is why it's showing as J-Link, but it's accept. I'm going to convert it back to ST-Link. You can always do that. I'm just going to do it so everyone can start from the same. See, that is changing the firmware of the debugger. So when I go to the device manager, now I no longer have a J-Link, I have an ST-Link, see? An ST-Link virtual COM port and an ST-Link debugger somewhere in here, right? So this is the way you should be starting. When you're connecting the board, if you are on the desktop computer, you should be seeing an ST-Link debug and an ST-Link virtual COM port. Does everybody see that? The ones that are on the laptop, if you don't see anything, if you see an exclamation, is because you need to install Cube Programmer. Where do you download that one from? You go to ST Tools, Tools and Documentation, ST Tools, and then you go to Cube Programmer. If anybody uses Linux, I have the tools here for Windows, but all these tools are also available for Linux and for Mac OS.
You just have to find them.
Yeah, but I can guide you through that. It's not too difficult.
Sudo apt install blank.
Any questions up to this point?
Build the binary from the target.
Okay, so if we are ready and we see our board as ST-Link, what we're gonna do now, we're gonna convert it to J-Link. Okay, so it can work with Seger with no problem. And how do we do that? We go to Tools and Documentation, and we look for Seger tools, and we download the ST-Link Reflash utility, which is a portable thing that I just executed. And when you double click on this guy, it opens a DOS window. You have to accept twice. If your board is already J-Link, and for some reason like myself, I wanted to make it go back to ST-Link, I can do so, but I'm assuming that everybody's board right now is ST-Link. So it requires to do an upgrade to J-Link. So we need to select number 1. And that's gonna tell us to wait for 10 seconds, and it's gonna reflash the firmware on the debugger, and it's going to convert the ST-Link to J-Link. Moreover, when we go now to the device manager, again, it no longer shows an ST-Link, it shows a J-Link. On both the COM ports, as well as the J-Link drives.
And we want it to be in J-Link specific.
We want it to be in J-Link because that's when it worked well with Seger with no issues. Anybody struggling? Yeah. Did you install Cube Programmer?
I just did.
Okay. Did you open the Reflash utility? Because with Cube Programmer, now you should be able to see the board as ST-Link. Bring the laptop.
What's it called on the desktop here? Because we're obviously it won't let us install it. We need to be. I need admin username password.
Oh, for here, no, but not for the Reflash utility. That's a portable.
You said it's already.
Oh, yeah, just download it in some folder that's here. Oh, that's
Wait, you didn't, what, yo,
And you do this.
Oh, I think you may have, oh, you have, something is asking you there. So, oh, it's because you needed to install it, did you? Okay, you have another one open here.
I'll push the J.
But you opened like 5 of them. You were being a little impatient there. Can you open this, expand those to see if it's showing up properly? Yeah, the other one, the other USB. It's not showing anything. So my guess is that this cable is actually not working. What is the other one? Let's try one of this.
Why is this online? Yeah, try that one. You know, it's just like,
Not showing up. The cable is somehow is not. So it's showing now as SSD. So what you're gonna do now, you gotta download the Reflash utility. You download it already? reflash. Did you unzip that one? You have to unzip it. Oh, it was already unzipped. That's what we did. Double click on that one? No, that's the DLL. Yeah. You never click on a DLL file. Okay, accept with a capital A. Okay, accept, and accept again.
ALF files and run random scripts off the internet?
Now you want to upgrade to JLink, number 1. Okay. Now we're going to updates. And now it's already JLink. So if you go to the device manager, it no longer shows an STD, but it shows a JLink. Now, here's the thing. The ones that have laptops, you may be seeing a problem. And
Yes.
how can we actually do this? Because Carl is already here, maybe we can use this. Can we actually point to this screen? I'm not so sure if that's gonna work. You may be seeing that problem, bulk interface or whatever, okay? So what you wanna do, did you install the JLink software? Okay, so what you wanna do, you wanna right click on this guy, because for some reason Windows doesn't like the drivers. You're gonna say update driver. You're gonna browse. You don't have to do this on the desktop computers because this is already installed for them. And you're gonna browse, and you're gonna look for wherever the JLink software is installed, which is in my PC, C, program files, Seger, and then no, you don't have the JLink software installed. You have to go to okay, the ones that have laptops, you need to install the JLink software and it gets downloaded from here. Yeah, in fact, this one is the newer version. It's not. Yeah, that's the one that you need to install. Why did you install it? You need to install the program. No, this is the ST Reflash utility. I'm talking about the JLink software. This guy. It's up here. No, this one. No, this one. Right. Let's go with the default. Okay, the guys who have laptops, again, you need to install the JLink software and you need to update your driver and give it that path for it to update. It's a Windows thing. It didn't used to happen before and now it's happening after certain updates. Okay, so let's see if we can do this again to show to everyone.
Oh. Okay.
So,
Show
I'm
demonstration.
gonna try to show this. Go to your device manager. And look for the driver that doesn't show properly and update the driver to this JLink software folder that you have there. Next, it's gonna upgrade the driver. And it should show up as a proper JLink now. Okay, it should show up like that. Down here, as a JLink driver. Where's the mouse? Here. This guy. But we also need to update the COM port as well. Update driver and give it the same path, JLink. And then do that, and it should also update. I'm gonna add a video. I did this online on Saturday too, when I helped the guys. There was a video I recorded the video is already on my site. It's just using the older board, but the procedure is the same. That's the
Yes, thank you.
Okay. You're good to go now. Yeah. How are the guys with the laptops on the back there doing? Everybody who's with laptop, any issues? No? It's working fine? Okay. Okay, but did you convert to JD? Is it being recognized as an STD? Let's check that first. I click on the device manager. Okay, we're gonna take a break till 8. Okay, so I'm gonna help the ones that are struggling. At 8, we're going to recap. Okay, so let's see what is showing up. If it shows nothing, it's okay.
I have another one.
I'll be with you. Okay, sorry, I'm sorry. I thought that you were calling me. Okay, Carl knows the process now. He can help everybody.
Yes, Carl. Let's go.
Okay, so let's try one of these guys. Yeah, the USB cables, if they're not proper data cables, they won't work. Okay, so where do you have a USB here? There you go, right away. Okay, so where is it? Because I saw this thing. No. Okay, so scroll. You have some things that are all in your face. So did you already convert it to STD? You did that, then you convert it? Okay, so what you need to do now is go here. Right click on that box in the face. Update driver. Browse.
But the one is new one.
Browse. See program files. No, that's more 32 bits. Then that goes to second. Expand that and go to James. And down next. Now you have a James driver. Now go to the COM ports. Here, COM ports. Above. Let's expand that.
Cable shit.
Right click on that one, do the same thing.
Oh, it doesn't connect? Really?
It's the same location.
Wait, so are you borrowing the one?
Don't change anything.
It's so hot in here. What are you talking
It's like, I don't know if I have enough room for Joy. No, just, he's going out to suck on some peach flavored nicotine juice.
The stairs is downstairs.
Thanks. The stairs are downstairs. I didn't know that before. Now I do.
The
That's
stairs are
good.
downstairs.
That's right. You know what? I wasn't
Yeah, as long as you're
before,
not
but
debugging,
now I have.
Okay.
Yeah.
So yours is.
And it's also, you know, you gotta go back up the stairs.
I just thought.
Okay. So did you have to do the path?
Don't go downside up.
The driver and all that? Yours. Yeah, you have this problem.
This is going downside.
Is it being better?
Maybe that one is new. That's the one from the new here. That's why you need to. Oh.
Okay, so this, what you need to do is you need to right click in here.
Not all. The second that you use.
Assuming driver.
You see driver. Find the C driver.
You gotta do the same thing for the comports. Now it's just wait for it. Turn on here. Yeah, just go to program files. Save it. And then look for JLink. Yeah, that one. Select that one. Okay. That should update. Next. Okay, close. And then go to the comports. You have to do the same thing for this guy. Have the driver. Browse. Don't browse anything because that's already there. Just go next. And that's good. So that's done. Anybody else? In this computer, only do the reflash. The conversion from the Q program and nothing has to be installed.
Yeah, currently. Yeah.
Not being recognized. Yeah, it's
And the error.
Just getting reflash. Just give me a second. Oh, you give it back? Why?
I don't know that works.
Oh, it works now?
Yeah, it works.
Okay. Okay, who needs a cable? Here. Okay,
Apparently most of the class needs new USB cables.
USB
cables suck.
You're back!
I'll be back.
Yeah, I teleported up here. Yeah.
You found your way up.
Yeah, I had to pop on a Google Maps real quick. I got lost.
Yep, I know. Real complicated out there. I don't even have to see it.
Actually, it kind of sucks because I can't even like actually work on.
So, long story short, so I gotta go find the tools and then install them in Linux way. They're new for me. Which is fine, it's like, from what I've read up, most embedded developers end up just, it's easier to do things from like, you don't have to fight against the Windows, like everything. On that system, dude. I don't know why it doesn't make any sense. Well, everything's sandboxed. It also makes things, it makes it difficult for other stuff to talk to other things.
Pick a color.
If you build an app to do the thing that we used to do with the paper,
Please try.
Oh, no way. Anybody else still needing help?
Yeah, can we build some new cables? Real quick and dirty, let me know which pin I need to insert for data. What's the question, Joe? Red or black? No, red.
The right line, 8% population, very electronics, very easy.
Make some money, bro. Did you lose or win? Hell yeah, Brett.
It's the red zone. But you said double down. I was scared of something, to be honest.
Is your real money going? Are you, is it real money going?
That's
Why?
Assembly the.
Who are you, man? Yo, I gotta respect that though, because I don't have enough balls to do that. I wouldn't be, I couldn't. I'd be like, no, I know I'll waste my money.
That's how you got it.
Here's the deal, like, it's risk tolerance, right? Okay, so you're like 20, 22, alright. Yeah, so your risk tolerance is gonna be a lot higher than different people have different risk tolerances, but normally the younger we are, the more risk we can handle or take on.
Okay.
And still be able
There's some
to
wisdom
recover.
right here. There's some wisdom.
And still be able to recover, right? So at this point in one's life, your risk tolerance is fucking sky high. You could play bankruptcy tomorrow, and you'll still be good by the time you're 30.
That's crazy.
I really hope that it doesn't happen though, because like that would be insane. But still, I'm just saying, if you got completely dove right now financially, and you had to go like negative $1 billion,
Yep.
you'd be fine by the time you were 31.
It's crazy. He doesn't know what I'm talking. That's not common. That's the reverse of you saying.
That means you're all in.
Everyone good?
Oh, yeah.
Everybody, yeah.
Okay, time to walk. I gotta stop. What time is it? Oh, I got 2 minutes to like get water.
Right now, Zorda. Long story short, it's the Ubuntu-based distro, and it is the most Windows-like TV show. I'm like, it's gotta go through the boot sequence, and it actually doesn't take this long, it just has to go through all of this, like,
Cause it did post a bunch of videos. Cause I
it is no base, but this is my,
It's literally like Windows.
yeah, I've obviously used their like basic customizations, so like there's, you can go into appearance, and you can change the you can change the layout, it says pro, you'll change that shit, you can just like type it in command line, and get it done, but it's very weird, like, when you start making, you can even do this. Display it's like, it's just what we're used to. So like, the first that you buy the item, like, buy,
I like it.
I don't know, you can get
Yeah, cause I use Hyperline, and it's very bare bones right now. I've been adding.
you like an arch rice? Yeah, no, I was running arch.
It was, cause sometimes it's so like, so it's like, you gotta like find from whatever, like Reddit, YouTube, on how to solve it, and it's like, it doesn't even work because that's already too late.
It was like 2 or 3 weeks ago, which means that you're already down your March, let alone the current. You're like, oh crap, okay. So like nothing works, and you're like, alright, and then you'll go like, yeah, that should be fine. And then it's got 6 different versions, you're like, fuck. Which one? And if you install one of them by accident, that one could be something that breaks a branch off of something. And if you don't have something like,
No, this does not do that. That's installed.
like you don't have.
It's the ST-Link Reflash utility. Guys, we cannot be the whole night doing this. This is, should be something that we are somewhat familiar with. We gotta be good at computers.
Your assumption is very.
Yeah. It can be that we cannot find where the files are. Like,
If you grew up with everything just working, it's difficult to understand how troubleshooting works because everything just works for you.
yeah.
You grew up in an era where you had to troubleshoot everything because your floppy disk wasn't connecting.
I
to
got
it.
exposed to the first computer when I was 19.
So Windows 3.1? Yeah. I was like, the second you said 13, you do some quick math, you're like,
I was
Windows
poor,
3.1.
so I didn't have a computer. Then I got a computer.
There's certain experiences, there's generational gaps in troubleshooting knowledge.
Okay, can I see hands of the ones that are still working on it?
My cable sucks, so it's not really the computer's fault.
Oh, yeah, but you can get a cable. Get this cable for now. Okay, the ones that are ready, what you should be doing, you should be grabbing any of the demos, even though those demos are not doing anything. But do this. Go to the in-class demos, which I hope I can find, and open any of the demos that we have. So how many demos do we have? Yeah, like even the structs. Open that one, okay? And change it now, in case you haven't changed it in the options for the project, change the debugger now from simulator to JLink. And connect the board, and it should be able to flash the firmware on the board. If you flash this, now if you want to see this window, if you don't see it, go View, Toolbars, Debug. View, Toolbars, Debug. And that will show this window here where you can just flash the firmware. Oh, I guess this thing should not be there.
Hey, it's failing
Now, see, now the firmware is actually running on the board. It's no longer running on simulator. Again, go to any of the projects that you have demos, go to the options, and change the debugger now from simulator to JLink. Here. And make sure you can flash the board. I'm gonna update this demo right away. Are you guys good there, Rosine?
No, I didn't vote.
Do you guys need any help or what?
Yes.
Go. Go to right click on the project and change. Okay, what's going on? Yeah, I have
No idea where the hell I put it.
Changing on the project. See, and you guys need to get a mouse because some of you with the touchpad are spending too much time. Options. Then make this bigger because it's bigger than the show. Grab it from the
What do you mean? I just don't have
go
files.
debugger, scroll down.
Options? No, no, no.
Double click on
No, no, no,
the.
no.
It's such a tiny screen, make it bigger. See, that's why you cannot find it.
Oh, yeah, yeah, yeah.
Way too much time on this, and I might fail the course, but I gotta work it.
can change
I
that.
mean, hey, if it works, no fix.
Guys, I don't mean to be mean, but I see some of you with the touchpad going like really slow. Get a mice or something. Like, we need to be quick at this. Yeah, because there's so many things to configure. We can't be that slow. We need to practice more. Okay? The good news is that if we're slow, with practice, we can get faster. Okay? I'm not even a fast typer. I've seen students that can type really fast. Probably 5 times the speed I can type. And I can still do things quickly. So, shouldn't be an issue for any of you.
That's right.
Okay? Okay, so again, what you should be doing is opening any of the demos, go to the project options and change the debugger. And the other thing I'm seeing is that some of you are getting a screen like this. So how are you gonna find things in here? See what I'm saying? Grab the thing from the corner, make it big enough, but obviously if you have a tiny screen, see, that's why you need the triple monitors and all that. You can't work with a tiny screen. Make this thing big enough so you can read what is in here. When it's all the way there, you cannot read that, see? Okay. This is something.
Yeah, you two ultra wide in the middle.
Yeah, and you double click on this. When I say double clicking, that's yeah, so you double click
J-Link, yeah.
J-Link, and then you change it to J-Link just in case it's not J-Link. Okay, we need to go back to this. Okay, so we're gonna do now, we're gonna create a new demo. So the way I'm gonna do that, I'm just going to copy the project. That's the way I've been doing it so far. So I'm going to create this demo.
Is it in the folder?
You just copy the folder and make it 9, and that's it. Well, you have to create it in your own, right? Because you cannot.
Oh, yeah.
And I'm gonna say board demo 1. Okay. Up and I'm good. Oh, we still have that. Okay, so we're gonna rename this guy and delete the other 2. And then when we open this, we're gonna make sure we also change it inside in the project here. Rename it to something that makes sense. Okay, and rename also the, just because I wanna keep the settings. Yes, Carl?
Yeah, how did you get the J-Link?
Oh, right click on the project, go to options, select debugger, and double click in here and change it from simulator to J-Link. Whenever you create a new project, by default it's gonna be J-Link. Okay, so. And you expand the source files and look for your main, okay? I'm going to erase it, bit 1, whatever, because we're not gonna use it anymore. I'm going to delete also the struct. I'm going to delete everything. The only thing I'm going to do is including this library that I already included before, which is, this library is the one that contains the entire memory mapping for the micro and the registers and everything that we're going to be using, okay? Also, most likely our micro needs to be running an infinite loop. So how can I create an infinite loop? With while 1. Why 1? Well, I could do while 5, while 1000, doesn't matter, because anything different than 0 is true, right? This is equivalent to doing a while true. And that way this thing is gonna be running always, okay? Now, let's go to the site for a moment, and let's take a look at the next lesson that we need to do, which is the micro header file. Okay? Oh, I have a typo. Okay, the purpose of this lesson is understanding this library that we're including. Okay? understand its purpose and how it maps to the peripheral registers. Now we're talking about registers that have an address in memory, okay? Learn how to use the bit masks to actually set bits or clear bits, depending on what do we want to do, okay? And we already know how to set clear and toggle bits, right? Because we've been discussing it for the last couple of weeks. And we're gonna write a simple code to control a GPIO using register level programming, okay? Now, what is this library? This library is part of the CMSIS, which is the Cortex Microcontroller Software Interface Standard, okay? Provides definition for the peripheral base address. Basically, it gives names to all the peripherals, like GPIO A, GPIO B, and it contains an address, okay? All that is defined. And it has memory mapped structs, just like we showed you before, structs with all the registers inside. For example, this is the first struct that we're going to be looking at, and this is a simplified version of the actual struct. The one that I showed you before, it had more registers. And the GPIO will have all these registers, okay? And each port will have 16 pins in general, from GPIO 0 to GPIO 15, okay? So the ports are not 8 bits like we were showing in the abstract that we were doing, it's actually 16 bits. And where do we find all this information aside from the library? In the reference manual. Which reference manual? Reference manual for the micro. So we go back to our lesson 2 and we scroll down and see in the MCU resources we have 2, the datasheet and the reference manual. So I'm going to open the reference manual. And actually your reference manual, in case you haven't noticed, is also in the repo that you created. The repo that you created has a docs and an MCU subfolder has the reference manual in there.
Sorry, really quick, we have write access to that folder.
Yeah, you got right access to everything except
Except
the
in-class.
in-class demos.
Thank you.
Yeah, so you can change that name for that, whatever you want to do. Now, these documents is like the Bible for this micro, okay? And it's 1,300 pages. So, do you need to memorize it all?
Yes.
Yes, of course.
What?
No,
Oh.
obviously not. Did you need to, if you ever read the Bible, did you need to memorize it all? No, but it would be beneficial to learn how to look for something. Like you need to go to Apocalypse, whatever, verse, whatever, chapter, whatever, should know how to find it. This is kind of the same idea. So everything is grouped in chapters, okay? And in the chapters, we're going to look now for the GPIO because the first thing we want to do is toggle on LEDs, so we're going to be able to handle a GPIO. So GPIO is actually chapter, which one? Sometimes it's hard to find. General purpose input output, chapter 7.
Oh, is that? Okay.
You click on the chapter 7 and you have some sort of introduction with a diagram that is very confusing.
Yeah.
But the most important thing here is you expand this markers and you go to the GPIO registers. That's what you are interested in because the GPIO registers are the ones that you're going to program to either ones or zeros. Okay? What is the goal of this program that I'm building? My goal here is to configure LD4 to blink. Okay? And LD4, which port and pin is it? Does anybody remember? I didn't write it on the board. Where can I find it? No, not in the reference manual because the reference manual is the manual for the microcontroller. How do I know where LD4 is connected to?
In the schematics.
In the schematic could be one option, right? So if I go to the schematic and I look for LD4, it's connected to what? Huh? PA5, excellent. So we're gonna set up PA5, okay? Now, here's the thing. PA5 is port A, pin 5. Okay? Now, that's connected to the LED. Now, the first thing I gotta do before I can use this, what is it? Well, I need to somehow to tell the system if this thing is gonna be an input or an output, because it can serve two purposes. It can be general purpose input output, okay? But before I even do anything, here's the thing. In this micro, since it's low power oriented, everything is disabled by default, okay? So since everything is disabled by default, we need to enable. Basically, we need to enable the port A, the port B, whatever we want to use, we need to enable it. And that happens in the RCC, which stands for, if we look at the reference manual again, and we look for RCC, I think that one is chapter 5. It's called Reset and Control and Clock Control, okay? So in the RCC, if we use arrow operator, see the IntelliSense is gonna bring up all these registers. There are so many, right? And everything gets connected eventually to the RCC. And in particular here, we're looking for the IOPENR register.
Eye opener?
Yeah. IOPENR, yeah. It's something. Well, if you're curious enough, and in fact, you should be curious enough to look at this, and go to, see, every chapter is the same. The RCC, you can go to the registers and find this IO, whatever it is called. So this guy here. So this is a 32-bit register, right? But you're only using the 6 least significant bits. And each one of them enables a port. And there's something very important about every register that we need to learn how to read. Is the reset value. So the reset value is the value that the register will have when the micro powers up or when after it restarts. So that is the default value. So in most cases will be zeros, all zeros, but not always. So make sure you pay attention to this. So, and what does it say? For example, if we look at the GPIO-D, well, 0 is disabled, 1 is enabled. So then, by default, everything is disabled. So we need to enable it, okay? So if we want to use GPIO A, it's A5, right? GPIO5. If we want to use GPIO A, we have to enable it in the clock. So how do we enable that? Or equals, because we want to set a bit, right? Now, GPIO A is the bit 0. So I could do something like this. Okay? However, I said at some point that you easily get sick of the ones and the zeros, especially when the thing starts growing, right? So you want to be using masks. Are you going to be defining those masks? No, because they're already defined in the library. So if you look and rewrite this, see, and everything is semantic, it has the same name. Pay attention to what I'm going to do here. So I'm going to type RCC underscore IO, look at this. GPIO enable. You can use the enable or enable underscore mask. Either way works. Done. So that is enable GPIO A. Now, how do I know this is the right number?